In this video, we are going to talk about logarithms, and specifically, we're just going to talk about logarithms to the extent that we need to in order to be able to understand pH and solve for the pH when we know the concentration of hydrogen, or solve for the concentration of hydrogen, for example, when we know the pH. So it won't be a full discussion of all of the things that you could know about logarithms, but it'll be good for our purposes. So, when I was looking for ways to explain logarithms that made a little more intuitive sense, I found this explanation on mathisfun.com, so I'm borrowing this from them, but they explain that in their simplest form, logarithms answer the questions, how many of one number do you multiply to get another number? So for example, how many 2's do you have to multiply like times each other to get 8? And the answer is 2 times 2 times 2 equals 8. So you had to multiply 3 2's to get 8. So to connect that to logarithms, that same problem can be written as 2 to the third equals 8. Or an equivalent way to write it is log base 2 of 8 equals 3. So what that means is the number of 2's, notice how the 2 comes first, the number of 2's we need to multiply to get 8 is equal to 3. And I'll show you how to kind of convert back and forth between those two forms in a second. But again, we say that out loud as the log base 2 of 8 is 3, and log is just short for logarithm. Base 2, it's called base because 2 is the base in that first equation on top. So it's 2 is the base, 3 is the exponent. So it's the log base 2 of 8. And here's that same equation, so 8 equals 2 to the third, and I'm just going to show you what I do in my head when I'm converting to the logarithmic format is I think, okay, the exponent drops down and becomes a big number, and then the base scoots over to the other side and becomes a little number, and then you write log in front. So 8 equals 2 to the third is equal to the log base 2 of 8 equals 3. Those two equations are equal to each other. And another way to think about logarithms is kind of as a way to undo an exponent. So if you were trying to solve this in your algebra class, you might notice that you can't you can't solve this by like adding or subtracting or multiplying or dividing because that x is an exponent, and so none of those things will bring that exponent down. So the way that you solve for that exponent or bring it down is by taking the logarithm. So now that we've taken the logarithm in the bottom half, the x is now a regular sized number and we can solve for it, right? And again here, b is base, b stands for base, and x is the exponent. So the log base b of y equals x, or b times itself, x number of times is equal to y. And again, just to show you how you would convert just back and forth between those two equations, drop the x down, scoot the b over, and you get log base b of y equals x. There are mathematical reasons for doing this, but for the purposes of just understanding pH, I'm just kind of giving you the shortcut. So here's a numerical problem. We have 1 million equals 10 to the x, and we need to solve for x. So what do? We take the logarithm. So the log base 10 of a million equals x, just converting the same way we did in the other problems. And all you actually have to do here is put a million into your calculator and hit the log button, and you will get 6. So x equals 6. Then it's a good idea to check your work. Plug that 6 back in. Does 10 to the 6 equal a million? Yes, it does. We did it right. I want to show you one rule related to logarithms that can make the math a little bit easier. If this rule is confusing, that's okay. You don't need to use it. It's just convenient if it makes sense. So in the same problem, a million equals 10 to the x. Maybe you know that a million is 10 to the 6 when you start the problem. So you could just look at that right away and say, well, 10 to the 6 equals 10 to the x. X must equal 6. That would be easy, that would be correct, but in order to show you this rule, we're going to solve it by taking the logarithm anyway. And the rule is that when you take the logarithm base 10 of a number that already has a base of 10, the logarithm and the base cancel each other out, and you're just left with the exponent. And that works with other bases too, but we're just going to talk about log base 10 here. So log base 10 of 10 to the 6 is equal to 6. I didn't even have to use my calculator, and I can double check that 10 to the 6 equals a million. Yes. For pH, we are just using log base 10, and that's because the concentration of hydrogen tends to be written as 10 to the something. So like if the concentration of hydrogen is 10 to the -7th, then the pH is 7, and that's convenient. So we're just going to worry about log base 10 because we talk about hydrogen in the terms of 10 to the something. And logarithm base 10 is kind of the default or the standard logarithm. So if you ever see logarithm written without a base, you can just assume it's base 10. The logarithm button on your calculator is base 10, so you can just use that. So here's how you might use this to solve a pH problem. We know from the previous video and your book that pH, the formula for pH is pH equals negative logarithm of the concentration of hydrogen. So if you knew that the concentration of hydrogen was equal to 0.002 molar, then you could figure out that the pH is equal to negative log of 0.002. If you put log of 0.002 in your calculator, you will get negative 2.70. And so pH is equal to negative 2.70, which is equal to positive 2.70. So even though that seems like a small concentration of hydrogen, it's actually a pretty acidic substance. You could also solve for the concentration of hydrogen if given pH. But I gave you another formula to do that with in the other lecture, so you can just use that one too. So the pH scale, sorry, and just to clarify, let me think about what that was. The other formula was the one that was like concentration of hydrogen equals 10 to the negative pH. So if you're given the pH and you want to find out the concentration of hydrogen, it's easier to use that equation, I guess. Okay, one thing that I forgot to point out in the other video is that the pH scale is logarithmic. That means that when pH changes by 1, the concentration of hydrogen is actually changing by a factor of 10. That means there's 10 times as much or 10 times as little hydrogen, depending on which direction you go. So if we start with a pH of 0, which is really, really acidic, it's a really high concentration of hydrogen. You have the concentration of hydrogen is 1 molar. If you increase pH by 1, which means you decrease the concentration of hydrogen by a factor of 10, then now you have 0.1 molar. If you go down another step, you divide the amount of hydrogen by 10 again, so now you have 1/100th, 0.01, and then you go down another step and you have 1/1000th, and so on. So it changes pretty quickly. And if you go up or down multiple steps, it's times 10 for each step. So if the pH changes by 2, for example, if you go from pH 0 to pH 2, then the concentration of hydrogen changes by a factor of 100 because 0 to 1 is times 10, 1 to 2 is times 10. So going from 0 to 2 is 10 times 10 or 100. So just know that, that changing the pH by 1 unit changes the concentration of hydrogen by 10 times as much or as little, depending which way you're going. Okay, so that hopefully is what you need to know about logarithms for pH. I'm going to try to put some practice problems up on Wednesday so that you can work through the material yourself a little bit.